Welcome to the Green Urbanist, the podcast for urbanists fighting climate change. I'm Ross. Hello everyone. Today's episode is a fascinating conversation with Jeff Rissman.
My name is Jeff Rissman, and I'm the Senior Director of the Industry Program at Energy Innovation, which is a nonpartisan energy policy and climate think tank based out of California.
Jeff joined me to talk about his new book, which is called Zero Carbon Industry. And in particular, I wanted to talk to him about decarbonising the industrial sector as it relates to buildings and infrastructure and urbanisation in general. So we really focused on talking about concrete and steel as two huge contributors to industrial emissions and global emissions, and being core elements of how we are creating cities, constructing buildings and infrastructure, etc. And so we have this, quite wide-ranging conversation of, what are the likely pathways of decarbonising these two, really intensive materials? What role does policy have to play? Turns out that Jeff, he told me just before we started talking that he also has a master's degree in city and regional planning. So he was totally tuned into all things like circular economy and adaptive reuse of buildings and efficient use of materials in architecture. So yeah, we had a really interesting conversation. But on top of that, he's also just incredibly knowledgeable about how all these materials are made, how all the industrial processes work, all the new and upcoming technologies for decarbonising them and electrifying them, etc. So yeah, it's a really, really interesting conversation. I learned a lot. It was very eye-opening for me, and I think it should be interesting for you as well. Just before we jump into the conversation, just to let you know that his book Zero Carbon Industry is out on the 27th of February 2024, and it's available for pre-order now. The link to have a look at that is in the episode description, so do check that out once you've listened to the conversation. If you are enjoying the Green Urbanist, and if you enjoyed this podcast episode, please do share it on social media or with a friend or a colleague. That really helps the podcast grow. Another thing you can do if you're listening on Spotify or Apple Podcasts is to rate and leave a review for the podcast. So that actually really helps for more people to see it, for it to climb in the rankings and get recommended to more people on those platforms. So that really does help. Okay, enough of me yammering on here. Enjoy the conversation with Jeff. The reason I wanted to have you on was you have a new book coming out. Can you tell us what is that book about, and what's the thesis of it?
Absolutely. The book is Zero Carbon Industry, Transformative Technologies and Policies to Achieve Sustainable Prosperity. It's being published by Columbia University Press on February 27th. And the book is trying to fill a gap in awareness. So there's a lot of attention is paid to how to clean up electricity generation through solar and wind, for example, or vehicles through electric vehicles. But people don't pay as much attention to how to decarbonize manufacturing, in the industrial processes that produce cement and concrete and steel and plastics and all the materials and products that we rely on every day. But globally, those processes are responsible for a third of human-caused emissions, including the electricity they purchase. It's about a quarter of human-caused emissions, excluding the purchased electricity. Either way, it's a huge share of our global emissions footprint, and we can't solve climate change without a shift to clean industry. This book aims to provide a comprehensive guide to what are these industries and how are they producing their emissions? What are the exciting technologies that are enabling a transition to clean industry? And finally, what are the policies that policymakers can enact to help ensure that these technologies are commercialized and scaled up?
Excellent. So, okay, sounds really fascinating and sounds absolutely super important. And we'll get into more of the city scale stuff in a moment, but I'd be interested to know what are the sort of main, I suppose, industrial processes or materials that you cover in the book that are sort of the big hitters?
Sure. So while the book covers the entirety of industry and manufacturing, there are some specific materials that stand out. The three highest emitting industries are the iron and steel industry, the chemicals industry, which produces plastics, which are used in building quite a lot, and the cement industry, where cement is the binder in concrete. So it's the building sector is the overwhelming consumer of that.
Mm.
So there's tight linkages between industry and industrial emissions processes and the choices we make for how we build our cities and infrastructure.
Yeah. And I suppose, well, maybe let's get started into this question of concrete and steel, because I think, just, I suppose, probably listeners of this podcast will know, but just to set the scene a bit about the fact that, society is rapidly urbanizing around the world, and we're moving quickly from 50% of the population being urban at the moment to probably 70% or above by 2050. And so, in that couple of decades time, we're seeing really whole new cities, whole infrastructure networks being built. And a lot of that will be built with concrete and steel as the main components. So to me, that feels like a good place to start, in terms of, what is a likely decarbonization pathway for these materials, if there is one.
It's a great question, and you're right that this question is growing in importance as urbanization continues around the world and in lower and middle income countries, particularly. There are good decarbonization pathways for steel and for concrete and cement. One option for steel is to increase steel recycling, where you take steel from demolished buildings and scrapped vehicles and put it into an electric arc furnace and produce new steel with it, which is a fairly low carbon process if fed by renewable electricity. Not completely carbon free, but far, far, far less, about 7% as much as making primary steel, non recycled steel. The problem is that we don't generate enough scrap every year to meet our full steel demand. So there isn't enough scrap to recycle. So we need a way to decarbonize primary steel making as well. And the leading technological contender there is a process that uses hydrogen, called hydrogen direct reduced iron. So you create hydrogen gas by using renewable electricity to split water into hydrogen and oxygen. And then you can use the hydrogen to convert iron ore, which is what you dig up out of the ground, to metallic iron, which is the main component of steel. That's already been demonstrated. There's a consortium of companies called Hybrid in Sweden that have produced zero carbon primary steel this way, and projects are underway to build more of these types of plants around the world, particularly in Europe. There are other steel routes based on direct electrolysis, where you use electricity to convert iron ore to metallic iron rather than hydrogen or fossil fuels. There are some startups working on approaches there, either at high temperatures, which is called molten oxide electrolysis, or with the iron ore ground up in a solution, aqueous electrolysis. Not to get too technical, but those are a little less technologically mature than the hydrogen route, but also are possible options. On cement, your listeners might be aware that concrete is this composite material where you have cement, which is a binder like a glue that holds together tiny bits of rock and sand, which are called the aggregate. So concrete is this mixture of cement and aggregate, and you can pour it into any shape to form buildings and bridges and things. The aggregate is not where the emissions are. It doesn't take much energy to crush up rock or gather sand, and you can do it with electricity. So the emissions are really come from the production of the cement component to concrete. And the way that's made today is that people put limestone into a large cement kiln, which heats it very hot, usually by burning coal, and decomposes the limestone to make clinker, the main component of cement. And that produces a lot of carbon dioxide, some from burning the fossil fuels and some from decomposing the limestone, which is calcium carbonate. There's carbon in there that comes out. So cement needs at least a two-pronged approach. One, to decarbonize the heat. You can heat the cement kiln and the precalciner electrically. And another approach to address the emissions from breaking down the calcium carbonate rock, which you can either capture using carbon capture. That becomes a lot easier if you've already electrified the heat, because then you're not mixing it with all the exhaust gas from burning the stuff. Or there are alternate chemistry cements that have lower or even potentially zero carbon emissions from their materials. So that's a quick overview of ways to decarbonize those two important building materials.
That's really fascinating. I mean, I think it strikes me that it sounds like a lot of the technologies we might need are already in existence, or at least in a small form and ready to be scaled.
Yeah, I think that there are many exciting technologies that can and are in the process of decarbonizing industrial production. For instance, there are a huge range of technologies to produce heat from electricity, which can deliver heat more efficiently than burning fuels for heat, and then is easier to decarbonize, because then you can supply the electricity from wind, solar, or other zero emission sources. So, and in many cases, all that's needed is to adapt a technology used in one area to a new area. For instance, we're talking about cement, where today the cement kilns are heated by burning coal. But there's a company, Cementa, that demonstrated that you can heat them using an electrical plasma torch. It's the same technology that's used in a plasma cutter, which cuts sheet metal. In that case, you don't have to reinvent a plasma torch. It already exists. So it's used industrially for cutting metal. All you need to do is adapt this technology to heating cement kilns. And there are other technologies that could perform this role, and so on. But it's an example of how a lot of the work that needs to be done now isn't at the fundamental research stage. It's just at the stage of engineering development or commercializing new products, like an electrical heating system for a different industry.
That's interesting. Yeah, fascinating. I mean, it strikes me that I think, fossil fuels are, of course, the villain of the climate change story, but I think we need to acknowledge that we really have built our whole society around what they can do for us, and the incredible, the incredible range of materials and processes that they allow through that, incredible energy density. Do you think that, what's the role for? It sounds like some things can be replaced with, we'll say, zero emission or lower emission technology, but considering the speed at which we need to decarbonize, what's the role of simply doing less, using less steel, using less concrete, etc.?
Yes, I'm glad you've touched on this, because material efficiency and circular economy approaches are so important. So the technologies I've mentioned can produce these materials cleanly, but even more cost effective than that could be to design a building or a product to be just as functional, just as useful, but use less material. And that's absolutely possible with smart designs that optimize material use and material placement. Just to give two, so the buildings and urban landscape are a good example of this. For instance, today buildings are often built using some buildings with metal frames use metal beams, and they have a limited number of metal beam sizes and thicknesses that they'll use on a construction site. And that's to keep things simple, right? If you have
Mm.
a smaller number of different sizes or thicknesses of beams, there's less complexity there. But it also means that you're going to round up. You're going to use the next heaviest, strongest beam, which may have more material than you need to provide the structural support you need in a given spot. So if you have a design that uses the material where you need it for support and doesn't place excess material, you can reduce the amount of steel needed in that building without affecting its ability to withstand load and earthquakes and so on. A similar example comes from pouring concrete, where typically it's poured into these molds and shapes that they put on site. They may block it off with wood boards, but you can pour it. You can create curved fabric molds that will place the concrete into shapes that place it where strength is needed.
Mm.
Or you can even create voids within the concrete using and this is again for spots where you don't need that strength, using an inflatable thing that blocks the concrete from entering that spot. And then so you can use less concrete if you're willing to do a few more steps that are not energy intensive in the construction phase. So the key there is to try to keep it simple and fast, since people want to be able to build buildings quickly. Time
Mm.
can be money for these, investments, and that's absolutely possible as these techniques become more common.
Yeah, yeah, it's interesting. I mean, within the sustainable architecture space, one of something that's commonly said is the most sustainable building is the one you don't build, and it's this real thing of checking, do we really need this? And I think the economy hasn't caught up with that because, of course, building things is good for GDP, is good for economic activity, but they're not. In terms of the carbon emissions and the environmental impact, it's not always worth it in terms of what society gets for that construction.
Absolutely. And in the vein of not building buildings when you don't need to, there's adaptive reuse. So, of course, you could take a structure that already exists, and maybe it's not a perfect fit for its location now because the neighborhood changed or the needs are different, but potentially it can be adapted. Changing offices to housing or changing a railway station to a hotel. And aside from being environmentally friendly and material efficient, that also can preserve historical character and make for some aesthetically beautiful structures. And then the other piece of not building buildings when you don't need to is building them for longevity and quality. So this is particularly an issue in some places like China, where the average lifespan of a building is 2 to 3 decades, and then they will tear it down and replace it. And given that China has a vast amount of urban infrastructure, if they're replacing all of that every 30 years or so, that's an enormous amount of concrete and steel that has to be produced unnecessarily. So, if buildings are built with sufficient quality, which relates to strong building codes and material quality, and are maintained properly, then buildings can last far longer than 30 years. They can last 100 years or more, and that is the less you have to replace a building, the fewer buildings you need to build simply as replacements. So adaptive reuse, longevity, and quality are all parts of the puzzle as well.
You touched on there about regulation and policy. What's the role of that in this decarbonisation?
Policy is very important. There are all of these wonderful technologies that are able to decarbonize industry, but the playing field is not entirely fair today. Fossil fuels don't have to pay for the full harms they do, either the damages they cause to the climate, nor to the public health harms, including the thousands of deaths that they cause in the United States alone from their conventional emissions, such as particulates, conventional versus climate or greenhouse gas. They emit both. And so they have this unfair advantage where they're causing all these harms and it's not priced into their costs. And so policy can help to provide a more fair and level playing field. There are a variety of ways, there are a variety of good policies that can achieve this. My book, Zero Carbon Industry, goes through a lot of them. One that I'll highlight here would be green public procurement. So governments, public agencies are very major buyers of building materials like steel and concrete, because not just for public buildings, which range from government offices to schools and so on, but also for infrastructure, all the roads and highways and bridges. So and government can generally choose what it wants to buy with its own money. So one policy that some governments use is to set aside a certain share of their purchases and say that they have to meet certain standards. So the government could say at least 5% of the steel in projects we fund has to be made through zero carbon primary steel processes. And that can help those processes, the hydrogen-based steelmaking I mentioned earlier, scale up because they now have the guaranteed buyer, and the steel company will be more willing to invest in a hydrogen-based steelmaking furnace when they know they'll be able to sell that output product to help build our roads and public infrastructure.
Yeah.
And then as that technology matures and as it gains scale, the costs come down. And then it can enter additional markets as costs come down. Government can increase the share of steel. It starts at 5%, maybe it goes to 10, 20, et cetera. And eventually then, you can transition to other policies like standards, which start to require lower carbon materials. Building codes are a particularly important policy in that regard, because building codes today mostly look at the properties of the building that they're making, the building's square footage and its environmental performance and such. They seldom look at the emissions that went into making the building's materials. Those are called embodied carbon emissions. But there's been some innovation in that regard. Just this past August, the California Building Standards Commission established limits on emissions from manufacturing the materials used in large commercial and school buildings. I believe California is the first state in the nation to factor these embodied emissions into its building codes. So that's a technique that the officials that set building codes, the commissions and such, can use to help ensure that buildings are built with cleaner materials. And then the codes can be tightened over time as the materials, commercial availability of low carbon materials grows.
Yeah, it's California always seems to be decades ahead of of the rest of us in many ways.
Well, California doesn't have a monopoly on good policy design, and I would urge policymakers anywhere to consider these measures, because it's really it helps companies also get ahead of the learning curve and maintain technological leadership. And And it's going to be necessary, not just in California, but across the country and across the world to meet our climate goals.
Yeah, it's interesting in different jurisdictions. I mean, I think in one of the frustrations with planning in England, from my experience, I'm based in London, is that really central government holds all of the cards, and it doesn't really give much power to regions or cities to sort of set higher ambitions. And the exception there would probably be London, which has a mayor, has the Greater London Authority, and it has been very good at setting much higher standards. And for instance, for major developments in London, there's a requirement that they're net zero carbon, in policy. So do you think that cities can have a sort of outsized role in driving forward these policies in really making a difference locally?
Oh, absolutely. Cities are so important in helping to establish the policy environment that will enable the clean industrial transformation. Um, in many places, building codes are done at the city or local level. Um, uh, Although, as you point out, in some cases it may be reserved for a higher level of government. But that can have advantages too, since you have the advantage of scale. If the higher level of government does enact a good policy, it will affect more localities.
Mm.
Um, so cities, but aside from the building codes, which can reflect the embodied emissions in the building products, alongside, of course, the building's performance, environmental performance during the building's lifetime, um, they also uh, can do set urban form. They can use green public procurement. There are financing mechanisms that apply at subnational and local and regional levels. It's fairly common for city governments in some places, including the United States, to offer tax incentives or other subsidies to companies that achieve certain public policy goals. Like, if you locate here in our city, we'll give you a tax break as long as you create a certain number of jobs. Well, there's no reason that they can't attach environmental goals to those types of incentives. They can also say, well, this tax break is if you locate here and produce uh, materials in a low carbon way, or this is a program that offers incentives to clean industry to locate here in our city. And then it creates high quality jobs for the residents of the area, and it avoids introducing the pollution that might come with an incentive that did not have those environmental requirements. So it protects your people, the health of the residents of the city. So it's a really good fit for cities in that way.
Yeah, it's interesting. I mean, my image of the sort of supply chain for these industrial products is that it's very globalized, and that we might be buying steel and other inputs from around the world. Do you think that sort of relocalization of this industry is part of the solution, or do you think we'll still keep with this sort of largely globalized system, or have I just got that wrong?
Um, Good question. Well, I don't have a crystal ball, but
Sure.
I do think that you're right that these commodities are traded internationally. Steel, even cement to a degree, although more of the cement and concrete industry, more of that is done locally, just because the materials are bulky and heavy, and the precursor materials are widely available in most geographies. So there's a little less of a reason to trade that in many regions. But so uh, just about every almost every country has an industrial base. It varies in size and composition, but there's an industry sector in almost every economy. So there's something that almost every policymaker can do to help clean up their local industry. I don't think that international supply chains are going away. I think there still will be international trade of materials, But these policies can apply to internationally traded materials as well. And that can help domestic producers sometimes. And there's, a major policy example of this is the European Union's carbon border adjustment mechanism, where there's a price on carbon emissions in Europe, and this mechanism means if products are being imported into Europe, whether it's steel or cement or other things, it looks at the embodied emissions, the emissions that went into making them. And if they don't meet these standards, there's a fee, which helps level the playing field for the producers inside Europe who have to cut emissions or pay the carbon pricing. And it basically extends this incentive to other jurisdictions, ones that may not even have their own climate policies. And it gives a reason for a steelmaker in some other country to clean up its operations. So policymakers in particular areas can do a surprising amount to decarbonize, even given global supply chains. And yes, it could drive some relocalization of production, particularly if there are incentives for that, like the ones I mentioned earlier. Some type of financial incentive for an industry to locate locally, if under conditions like it provides a certain number of jobs and it's using clean processes. So all of this is possible through smart policy.
Yeah, interesting. Can we talk a little bit about plastic? You mentioned earlier that plastic is widely used in the building industry as well. What's the problem with plastic at the moment? And then what's your sort of thoughts on decarbonisation?
Sure. So plastic is another important building material. Maybe not as much as concrete and steel, but a lot of pipes and things are made of plastic, and other plastic polymers and adhesives and whatnot. Today, plastic is made from petrochemicals. So they take the chemicals industry takes fossil fuels that are not burned for energy but go into other products are called feedstock fossil fuels, and they will convert the fossil fuels, petroleum products, natural gas, in some cases coal. China, for example, produces a lot of these feedstocks from coal. And then makes them into the petrochemicals, which are things like methanol and olefins and BTX aromatics. And from there, they get converted into the more familiar products that we're aware of, like the different plastic resins that are used in plastic bottles, and then the PVC pipes and buildings, and adhesives and so on, coatings, paints. So there are several mechanisms by which this process emits greenhouse gases. So there's these chemical transformations to make the petrochemicals and then make the products often involve input energy, heat, which can be supplied by burning fossil fuels, often natural gas or coal in China. So that's one source, the industrial heating. Also, the feedstocks themselves contain more carbon atoms than are in the output products. So the plastic has some carbon in it, but the feedstock fossil fuels had more. So the difference there is emitted as carbon dioxide process emissions during some of the processing steps. And then there are upstream emissions from producing the fossil fuels at the oil wells, which can include leakage of methane, a potent greenhouse gas. And then there's end-of-life emissions. So today, about a quarter of all plastics that reach end of life are burned, incinerated, which releases the carbon in them as carbon dioxide immediately. And that share is projected to increase to about 50% by 2050. And then plastics released into the environment, of course, have other problems with microplastics and health impacts, and they too may ultimately decay. there's a study that shows that microbes are evolving pathways to break down plastics, which
Wow.
in one sense is good because it could reduce the amount of plastic in the environment. But if it converts it to CO2, that's not a good side
Mm.
effect. So this is to say there are a number of reasons why we would care to decarbonize plastics as a building material and as a material for other purposes. Um, so how do we do that? Um, there are one option is to substitute other materials. In some cases, you can use, for instance, you could use paper bags instead of plastic bags in some cases. And as long as those are responsibly recycled or composted at the end of life, they're better for the environment. Um, than whereas they shouldn't go into landfill where they could turn into methane. Um, there are also plant-based plastic alternatives, bioplastics. You've probably seen those with cutlery and things. Um, and material efficiency, and which we talked about earlier, applies just as much to plastic as it does to steel and concrete. Um, and then there are ways to decarbonize the production of the petrochemicals themselves, mostly involving clean hydrogen. So if you start with hydrogen made from clean electricity, splitting water, you can use that instead of fossil feedstocks to make your petrochemicals. And then when you turn them into plastics, you can use it's the same methanol or same BTX aromatics. So downstream of there, it's the same processes, but the carbon in them are, had to come from captured carbon that you combined with the hydrogen, and so it's carbon neutral if you use that production route.
Yeah, I guess the building industry urbanization isn't the main driver of plastic use, is it? It feels like I suppose consumer products are probably driving more of that.
Um, the built environment is a significant share of plastic, but it's not the largest share.
Mm,
I think I may in my book Zero Carbon Industry I may have the breakdown, but I don't have it in front of me.
sure.
The But there's also packaging, which applies to the building industry as well, where a lot of these products are going to come in plastic packaging,
Okay.
for building materials as well as for consumer products. So I think it's a part of the mix, but uh, and it's important even whether or not it's the largest consumer of plastics, it's
Mm,
still a large consumer.
okay, fair enough. Yeah. I guess for me it seems like if we're hopefully moving away from fossil fuels as our energy source, moving more towards renewables, and we'll say harvesting less oil over the coming decades. That also means inevitably we'll have just less feedstock to create plastics. So we'll be needing to find alternatives, won't we? Or just using less.
Um, yes, I mean oil is an important feedstock for these plastic materials. Um, I and I certainly expect that we would be producing less oil. We need to produce less in order to meet our climate goals. I tend to think of it as more of a demand-driven thing. So we displace the uses of oil first, and therefore less oil is extracted.
Mm,
Um, so by using all of these techniques such as clean hydrogen and material efficiency and whatnot, we reduce our demand for oil, and then when there's less demand for it, less is produced. I think it's the other route, like less is produced, so there's a scarcity. I think is less likely to play out that way. So for policymakers, I guess I would emphasize finding policies to clean up materials, clean up the urban environment, and then the resulting impact on fossil fuel production will naturally follow.
what's the what's the role of economics here, in the sense that it's obviously incredibly profitable to be producing fossil fuels and to be producing the sort of dirty industrial products. How do you displace that sort of profit motive behind that?
Well, we'll still be selling the goods and services that people need.
Sure.
We'll still be selling buildings and vehicles and all of that. And there's no reason that someone would pay less for a well-designed vehicle or building that uses less unnecessary material, because just as you can pay for excess concrete that was placed somewhere, you can also pay for architectural and engineering design services that improve the quality of the building and allow less material to be used. So it doesn't necessarily reduce jobs. It can create jobs both through the investment in the clean processes and also in the design services and other areas that enable these products and buildings to be made in this more environmentally friendly way. So in terms of economics, which was your question, this can be an important driver of economic growth, where you want companies to invest money in new technologies, clean, new, modern technologies, and in their people, whether that's the workers who are creating these materials, whether it's the architects and engineers who are designing more efficient buildings. These investments create jobs both directly and then throughout the economy through the respending of money when these people and companies, when you're buying materials, use that money to purchase other things. And a lot of times it creates more jobs than the traditional way. Like fossil fuel industries are have a low labor intensity, meaning for every dollar you invest in them, a fair amount of it is going into capital as opposed to paying for workers. And also a fair amount of it is going abroad. So because there's still a lot of imports of fossil fuels. So they don't create as many jobs in the jurisdiction that policymakers in the UK and Europe and even the US and other places, Japan, et cetera, are responsible for. So this shift to cleaner industrial processes and materials can help to create jobs through smart investment and shifting the dollars from industries where they're not creating a lot of jobs locally to industries that do create a lot of jobs locally.
That's a really interesting element of this, I think. Yeah, thank you for outlining that. I wanted to shift a little bit because we've been talking about decarbonisation so far, which is obviously hugely important. But I'm also interested, what are your thoughts on the way that these industries have pollution impacts, but also biodiversity impacts and just environmental impacts beyond the carbon emissions? Do you see that improving with these cleaner technologies, and as we decarbonize, do they work hand in hand?
Oh, absolutely. So when industries are burning fossil fuels today to produce their heat primarily, and these fossil fuels don't just emit carbon dioxide, they also emit a range of pollutants. Fine particulate matter or particulates are the most damaging type for human health and the health of any other animals or creatures that breathe them in. But there's also sulfur oxides and nitrogen oxides that can create harmful health and environmental impacts. The acidification of water bodies is an example from not from particulates but from sulfur and such. So when you shift to a clean process, let's say you electrify that heat. You're using an electric resistance heater or an industrial heat pump or some technology like that. There's no combustion process at the industrial plant to generate the heat. So there are no particulate emissions, no sulfur oxides, no nitrogen oxides, and all of those environmental impacts go away. if the electricity is produced in a dirty way, there might be some of those types of emissions near the power plant, but we're already on a course to decarbonize the power sector through deployment of zero carbon electricity technologies. And in many ways, the electricity sector is ahead of the industry sector in driving towards zero pollution solutions. There are already detailed studies and computer modeling and such that show how you can get to a decarbonized electricity grid in various geographies, including the US and Europe and elsewhere. So for industry, electrification is a good solution because of the fact that the electricity grid can be decarbonized, and then and then that helps across the whole spectrum of these harmful impacts that that are caused by the industrial pollutant emissions.
I wanted to give you, before we sort of move on to the final points, I want to just give you a chance, if there's anything we've missed or any other like messages you wanted to give to the audience.
I don't think I've mentioned about the book beyond the intro. So the book Zero Carbon Industry aims to be the definitive guide to all these things we're talking about. What are the emitting processes and how to decarbonize them? What technologies are there, and what policies can policymakers put into place? And for that matter, if you're a citizen, what policies should you be supporting or asking your elected representatives to support? It's really essential reading for anyone who cares about how to solve the climate crisis, and in particular, this huge piece of it. You can find out more at zerocarbonindustry.com. That's the book's website, where there's materials from in the book, and there's a 20% off discount code there. At zerocarbonindustry.com.
Excellent. Okay, really helpful, and hopefully, I'll include links to that in the episode description, so people can just get there quite easily. Just before we leave, I think over the course of this conversation, we've sort of painted a picture of a future where we probably have, still living in a sort of industrial society where we can meet our needs, but maybe using materials more wisely, maybe not overusing materials, being more efficient, and also, reducing the impact on the environment of producing, those materials and those industrial processes. Are you optimistic that we can get there? And do you have a time scale in mind of how long this huge challenge could take?
Absolutely. I am optimistic that we can get there. I know we have the technologies that can decarbonize industrial production, and it's largely a matter of getting the right policies into place that help level the playing field, as I mentioned earlier, against the fossil fuel, the dirty technologies, and which gives the manufacturers of these technologies the incentive to bring them to new industries, the electrified cement kilns, and so on, and scale them up. And this is absolutely possible. You asked about time frame. I do address that in the book. I say that we could have globally. The book has a global scope, and I say globally you could get there by 2050 to 2070. I gave a range because not every country would achieve zero carbon industry at the exact same moment. Some countries are further along than others. Some countries have more money to invest. And the conclusion of the book talks about it divides this process into three stages, where which technologies and policies do you focus on first, and then later, and then finally. And one of the parts of this process is international collaboration. And the book talks about, actually, it has a whole chapter on how to make the transition to clean industry promote equity and human development, how it can help address some of these global challenges around inequity and poverty. And part of the roadmap is for some of these leading countries that can get there first to then lend help, license their intellectual property, license their technology, etc., to help other countries get across the finish line, lift everyone to the finish line. So I do believe it's possible, and it's possible globally, 2050 to 2070.
Fascinating. Well, this has been, I think, quite a hopeful conversation, and just want to say thank you so much for your time. You're a fountain of knowledge, and I feel like I learned a lot, and I'm sure the listeners will have as well. So thank you so much.
Well, thank you. I'm so appreciative of the opportunity to share with you and your listeners, and thank you for doing what you do with this podcast. It's so important to help share this information.